Space friend, I've been adrift in space for about 6 months now, and I've decided instead of being bummed out about that, I'm gonna commemorate it. Space is awesome, I got away with stealing this ship, and I'm lucky to be here. Even if there is some mysterious entity apparently taking control of my ship. But forget about that for now. We're gonna commemorate our time in space with a simple pixelated rocket ship scene on an OLED display. For this project, we just need 5 male to female jumper wires and an OLED display. Link in the description for the specific type of display that I'm using. We first need to include the Adafruit GFX and the Adafruit SSD 1331 libraries. GFX is for graphics, and the SSD 1331 is referencing the specific type of display that I'm using. I'll include a video at the end of this one that goes over OLEDs in more detail. Both of these libraries will need to be manually installed if you don't already have them. We also need the SPI library, but Arduino already comes with that, so you don't need to manually install it. We then set the variables for each of the display's pins, the clock, MOSI, chip select, reset, and data command selector. We're setting the screen width and height because we're going to use it to randomize the placement of some of the graphics that we're going to display. We also define the colors that we're going to use. I'll include another link in the description for where you can select custom hexadecimal color values if you want to use different colors. Next, we create an object called display to reference our physical display. Then we're creating integer variables to set the rocket's position and speed. The setup first initializes the display and then clears the screen out by filling it with black. Then we start a countdown. We set the color and the size and where we want the numbers to print on the screen. We divide the screen width, which we set as 96 by 2, so half the screen is 48. Then we're subtracting 12 from that so that the cursor is moved 12 pixels to the left of the center of the screen. The height works similarly. We divide the screen height by 2 and subtract 20, which is going to move the cursor 20 pixels above the center of the screen. After we print the number 3, we fill the screen with black again so that we finish the countdown by using the same format for the 2 and the 1 and the liftoff. Since this is in the setup, the countdown is only going to happen once, and then the rocket ship scene that we're going to do is going to loop continuously. In the loop, we start by clearing the screen again. The for loop generates and displays a set of randomly positioned stars. I is initialized at 0, so while I is less than 10, increase I incrementally by 1. This just runs through the loop 10 times. Int star x equals random screen width means that in each iteration of the loop, a random x coordinate for a star is generated using the random function. We do the same for the y coordinate using the screen height for the argument. Display.drawPixel colors a single pixel at the x and y coordinates we specified in yellow. This will generate randomly positioned stars across the screen. Rocket x plus equals rocket speed increments the rocket x variable by the value of rocket speed, which we set to 1. Rocket x is the x coordinate of the rocket on the screen, and rocket speed controls how fast it moves horizontally. By increasing it, the rocket will move towards the right. Then we have an if statement to check if the rocket coordinates are greater than the screen width, which would indicate that it's gone off of the screen. If that's true, then we execute the if statement and set rocket x to be minus 16. This will move the rocket off the left side of the screen, setting it up for another cycle of animation towards the right. Now that we've set up our background and movement animations, we do a rectangle and a triangle to create the rocket itself. For the triangle, we set the position of the 3 vertices and the color. Rocket x plus x and rocket y minus x are the x and y coordinates for each vertex. For the rectangle, rocket x and rocket y are again the x and y coordinates of the top left corner of the rectangle based on its current position. 16 is the width, 8 is the height, and we are delaying the movement by 50 milliseconds. This can be adjusted if you want a faster or a slower animation. Well, that was a nice distraction from the mysterious message I received last week, but now back to figuring that mess out.